Is that okay?
Yeah, that's fine.
Okay. So, polymers are large molecules built by linking many small molecules together. There's a lot of different types of polymers in this world. You are made up of many, many, many different types of polymers. For example, is anybody in here, have you taken or are currently taking Biology 30? Okay. So you hopefully have dealt with some polymers already. For example, Polyamorate.
Polymerase, yeah, that's a thing. Polygon.
But have you ever dealt with polypeptides?
Oh yeah.
Yeah. What about DNA?
Oh yeah.
Yeah. So you know how to make DNA, or you know the general process, right? Those are all polymers because they're made up of a bunch of different smaller units. So when you're making a polymer, just in general, this is the polymer we want to make. We have to string together a bunch of smaller versions of that polymer, or monomers. Does it make sense why they're called monomers? Yes, what does mono mean? One. What does poly mean? Multiple. Many, multiple, things like that, yeah. So the polymers, just many of these monomers strung together. In general, there are two types of polymerization reactions. There's addition reactions. Have we ever talked about addition reactions before? What do addition reactions have to start with?
Two double bond.
You have to start with either double bonds or triple bonds, right? So that's addition reactions. So an addition polymerization reaction is going to start with double bonds or triple bonds. And then a condensation reaction. I'm curious, when you think of condensation, what comes to mind?
Water coming back.
Yeah, water, right? And so basically, we're pulling out water from a reaction. So an addition polymerization reaction, you're going to start with double bonds. And you're going to break those double bonds and turn them into single bonds. But with a condensation polymerization reaction, you're pulling out water. So you're going to have water as a product. Now there's lots of different polymers. Those are biological polymers that we just talked about. We can talk about polypeptides, right? That's protein molecules. We can talk about DNA. That's made out of repeating versions of sugar phosphate, sugar phosphate, sugar phosphate, sugar phosphate, right? But we can also talk about polymers like this. What is this made out of?
Glue.
It's not made out of glue / horses, no. This is made out of, just in general, what do we call this? Plastic. We call it plastic. But there's... Yeah, the bottle.
In the bottle.
No, in the bottle is ammonia. Very dangerous for you. Yeah. Oh, okay. What? Can you what? Oh, did you say can you drink it? Oh, okay.
I mean you can, but I wouldn't recommend it.
Yeah, you can. You can do whatever you want, but I wouldn't recommend it. This is made out of plastic. What's this?
Rope.
Rope. But this is rope that's made out of plastic. It's made out of plastic, right? What's this container made out of? Plastic. What's this made out of? Oh, so it's not plastic, okay? What I want to ask you is on the bottom here, do you see letters underneath the recyclable triangle symbol?
Yes.
What do they say?
HDPE.
HDPE. So I'm going to write this down. I don't know, do you have any room anywhere on the top half of the sheet of paper to write some stuff down? Yeah, okay, sure. So HDPE. Now, I don't actually care that you know what this means, what this acronym means, but it stands for...
High definition.
No, close.
High density.
High density.
Polymer entity.
polyethylene. Ethylene and ethene are the same things. What is ethene? Two carbons, right? Ethene is just two carbons, right? That's all ethene is. The old school name for ethene is ethylene. And so if you ever hear somebody say ethylene or something like that, it either is this or it used to be this, okay? Now, does anybody in class have a relative that works for currently or used to work for a giant refinery just outside of town called Nova Chemicals? Seriously? Oh, okay. I was gonna say there's never a class that has nobody, no relatives or anything like that. This is what they make. This is basically all they do at Nova Chemicals. Wow. They make this and they make this.
Wow.
And so I'm gonna hand this. One of these, Ailina, I don't want to put you on the spot, but can you read the label there?
No. Polyethylene plastic.
Yeah, but is it high density?
Yeah, high density.
Yeah, it's high density polyethylene plastic, right? And then what's this?
Linear low density polyethylene straight from reactor.
Yeah, linear low density polyethylene, right? And so the high density polyethylene, if you want, you can pass it back and then it can kind of meander its way through class. And Mark, if you guys, if when you guys are done looking at it, you just pass it back and just make sure it makes its way back to me, because that's not mine, that's Z-Dog's. So I would like to give it back to him. So all Nova Chemicals does is produce high density, medium density, and low density polyethylene plastic. That's all they do. High density polyethylene plastic is made for like really sturdy containers. And this is really high quality plastic. You know it's not, there's no problems with it. It's going to be very durable over time. That low density stuff, what kind of plastic materials do you think would be made out of low density polyethylene?
Ziploc bags.
Oh, maybe Ziploc bags, right? What are some other types of bags?
Oh, garbage bags. Shopping bags.
Shopping bags, garbage bags, things like that. That's low density polyethylene. Styrofoam is not. The proper name for this, if you were to bring out your periodic table, your data booklet, the name of this is not styrofoam. It's called polystyrene. Styrofoam is probably the brand name. I don't actually know. Yeah, kind of like Band-Aid is a brand name as well. Yeah. So HDPE. There's also MDPE. What do you think MD stands for? Medium density, right?
Product for sale.
And so these high density polyethylene pellets, Nova makes these and they put them on a train and then they ship them out somewhere else, and then they're refined and they're produced. They take these pellets and they basically melt them down and use them to produce other stuff. Or can we give it to them?
Yeah.
Yeah.
Shift it over there. I mean, if you want to do it.
So, and then there's also HDPE. Sorry. LDPE, low density polyethylene. But there's all sorts of types of polymers out there. Look for the triangle and look at the letters below it. PP. So what does PP stand for?
PP. Personal protection.
That's PPE. This is made out of polypropylene. Now, if polyethylene,
No, that's the little one.
Yeah, that's the little one. That's the low density stuff. It's okay. Don't worry.
Chilling.
It only says it on the label.
Not a loose.
Okay. Hey, if polyethylene is made out of this stuff, what do you think polypropylene is made out of? Propane. It's made out of propene. Right? So this is what polypropylene is made out of. It's made out of this, but we're going to string a bunch of them together, and then we're going to make polypropylene. So there's polyethylene, and then there's polypropylene. This, again, is polystyrene. Polystyrene. There's all sorts of different polymers out there, and they all have very specific purposes. It just depends on what chemical you're starting with and what chemical you want to end up with and how you link them together. That's kind of where the devil's in the details. So let's go over some polymerization reactions. And some people have a problem with polymerization reactions. They have a really big problem kind of visualizing it. So we'll try and do this as clearly as possible. Please recall that addition reactions need a double bond in order to progress. This is the same as addition polymerization. Several monomers containing double bonds will react together to form a long chain of repeated monomers called a polymer. The production of polyethylene from ethene. So what does ethene look like? Double bonds, right? So we're going to take C, and we're going to have some H's here. If you have another color, it might be helpful, but it's totally fine if you don't have another color. It's all good. Hopefully you can see the green. Sometimes the green doesn't really show up very well. Can you kind of see how all we're doing is we're lining up a bunch of ethene molecules, and we're going to line up hundreds, maybe thousands of them in a row. And what we need is we need a little catalyst to start this off. We need a catalyst to kickstart it. But once we get the catalyst kickstarting it, let's think about this. How many hydrogens are on this second carbon here? Two. How many hydrogens are on the next carbon? Two. So normally, if this was the end of a molecule, if we didn't want the double bond here, how many hydrogens should normally be on here? 3, right? On a terminal carbon, there should be 3 hydrogens. But what we could do, if we want to get rid of that double bond, we could either add more hydrogen, but that's not going to make the molecule really bigger. What we'll do is we'll take the electrons from this double bond, and we're going to form a bond in between these carbons from these 2 separate ethene molecules. Does it make sense that if this half of the double bond just moves from here to here, this carbon hasn't actually changed the number of bonds attached to it. So we don't need to add any other atoms or anything like that. When we add this new bond to this carbon, how many bonds are going to be attached to it? 1, 2, 3, 4, 5. Is that allowed? Can we have 5 bonds on a carbon? No, so this new bond that's formed, what's it going to do? It's going to kick out that half of that double bond. Do you kind of see what's happening here? If we're going to make a new bond on this carbon, that's going to kick out the double bond, and it's going to continue on. It's basically setting up a chain reaction here. That's how this polymerization reaction happens. And so what are we going to get? What's our product here? Well, we have 2 carbons, And instead of being joined by a double bond, what are they joined by now? A single bond. And then that other bond is formed here, and it's connected to these two carbons with a bond connecting these two carbons with a bond connecting blah, 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 blah. So these are ethene molecules. Every single one of these are ethene. But when I string them all together, what are we going to call this now? Polyethylene or polyethylene, right? Because we could call this ethylene. That's the same name. So this is polyethylene. I'm curious. In polyethylene, are there any double bonds? No. Why do we call it polyethylene then if there are no double bonds?
It was made of double bonds.
Because the monomer had double bonds in it. Does that kind of make sense? The monomer had double bonds and we're stringing a bunch of them together. That's not the only way. That's not the only way we can represent this polymer. Do you see any repeating units of this polymer? Do you see any repeating units that can be instead of drawing, a bunch of carbons in a row? What's another way that we could draw this? This is the way I'm going to draw it. We could draw a bond coming in and our repeating unit. Would you agree these two carbons just repeat over and over and over again? Because that's the two carbons that they came from. This is repeating over and over and over and over. So I'm going to draw those, and I'm going to draw that they're attached to something else, and I'm going to put square brackets around it. And I'm going to say that this is repeated, and often if we don't know how many times it's repeated, we just say n, a certain number of times. For those of you in math 30, hopefully you would recognize that n is just saying it's any number of times, and we don't know how many times yet, but it's fine. So is that okay? This is representing the exact same thing as that's representing. It's just saying these two carbons repeat over and over and over again, blah, 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 blah. So let's try and look at some other examples. This is polyethylene. This is propene, right? So let's make some polypropylene or polypropene. This is still an addition polymerization reaction. So what's going to happen? I would like you to actually draw in here what's happening during this reaction. Are we breaking this first double bond? Jordy?
I'm just confused how that first double bond.
You need a catalyst to do it, and you often just need something to kickstart.
And then how does that affect the next one?
So, for example, on this side, if we had added, and this is, I'm going to get into some territory that I'm not very familiar with. I never really studied polymerization reactions very strongly when I was in university, but my understanding is you can just kickstart it with a little bit of a certain substance. For example, if we had H minus, have you guys ever seen H minus before? It's not a hydrogen ion, we call it a hydride ion. What can happen is this hydride, this negative, can attack this and kick out. If we form a new bond here from the hydride, if we form a new bond, this carbon has 5 bonds, it kicks out the double bond. And boom, 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 boom. And then all that has to happen is on the very last one, you just have to lose a hydrogen somehow. If you kick out a new hydride, then you restart the process over. Is that okay?
Yeah.
Okay. So here, do you see, can you recognize how this is propene? How many carbons are in this first chemical here? 3. It's 2 here, but then 1 down at the bottom. We're just trying to show you how this would work. So this first double bond gets kicked out, and it will kick out the second double bond, which kicks out the third double bond. Blah, blah, blah. So let's look at this middle monomer. How does the middle monomer change? It loses its double bond. So C, C, so it's a single bond now, right? Now what's attached to those 2 carbons? What's attached to the first carbon? 2 hydrogens. And what else is attached to that first carbon? The other carbon. Because that double bond is what kicks out that other double bond. So we now have a bond coming in and a bond coming out there. So we've got a bond coming in. What's attached to the second carbon in that middle monomer? A hydrogen on top. What's attached on the bottom? A CH3, a methyl group. And then it continues to go. This is, can you see how this pattern is just going to repeat over and over and over again? All we're doing is taking this substance and we're breaking the double bond. So carbon-carbon methyl group, carbon-carbon methyl group, carbon-carbon methyl group. So this is what it's going to look like. It's going to look like carbon-carbon methyl group, carbon-carbon methyl group. So if we were to draw this, hopefully you can see how there's a repeating pattern here. Can you see a repeating pattern in this polymer? What you should do is you should draw a box around the repeating pattern, and that can become your shorthand version of writing the polymer. Is that okay? I could show you the longhand version, but chemists are notoriously lazy, right? So I could just show you the shorthand version, and I would just erase all the other stuff. Sophia, seems like a question.
So why when the one carbon loses its double bond, it doesn't have like a fourth and a third hydrogen on the end, or do we just assume that because it's like always repeating?
It's continuing on the pattern. So you're right. I should have drawn and said dot dot dot. I should have drawn this and said dot 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 to show us that this pattern is it could be repeating for 1,000 carbons in a row, and that's just the way polymers go. Okay. This is what styrene looks like. Is it kind of similar to all of the other substances that we've seen so far? It's a double bond, but this time what's attached to one of the carbons on the double bond? It's a benzene ring, right? But this is what we call styrene. Styrene is a benzene ring attached to 2 carbons that are double bonded together. That's all styrene is. So what are we going to make if we have styrene react with itself 1,000 times in a row?
Polystyrene.
We're going to make polystyrene. And that's what styrofoam is.
You're saying styrofoam can cause cancer?
Benzene rings don't always cause cancer, right? Benzene all by itself, if you just had benzene with nothing else on it, is extremely carcinogenic. Super duper poisonous. Burning styrene is not, yes, burning styrene is actually not a good idea for you health-wise. Yeah. Max, did you hear that?
Yeah.
So apparently Georgie doesn't like it. Yeah. Okay, so without going into too much detail, what's going to be the repeating pattern? What's going to disappear from our monomers? The double bond. And we're going to get carbon-carbon single bond. What's going to be attached to that first carbon? A hydrogen and a benzene. What's attached to the second carbon? 2 hydrogens. And we just say that this is repeated n number of times. Do you know what I mean? That's all that's... Every addition polymerization reaction is the same as the last one. Okay? The last one, just give me a second. Yeah, perfect. So in the next slide, I would like you to predict what the monomers were. I'm going to give you like a minute or so to talk about what monomers were required to produce those polymers on the next slide.
Yeah, no worries.
It's pretty quick. It's my understanding it's a quite quick process. Yeah. But you would have to talk to somebody who actually works at Nova Chemicals because they're the ones who are making these polyethylene. That helps. That's what this is. And then they just take this and they melt it under very specific circumstances, right? Very specific conditions. And then they form it into whatever plastic shape they want. Yeah. Yeah, that's the start is very it's kind of outside the scope of this course, like the way you would kickstart it. You just have to have the appropriate reaction. Yes, I totally agree. It has to be starting. That's probably the hardest part for people that identify. I agree, you're missing a bond. Yeah. And so what will happen is you can actually get hydrogens. There'll be another molecule here, and this hydrogen. And it just under certain conditions that can happen. So that would be the start. And then on the next one, on the end, some missing. No, you don't want to do that. Just get rid of the brackets and draw. And then that's full. Well, I would draw 2 of them and then just go down. 2 of those molecules. Yes.
And the other one would be 1 chloroethylene?
Yeah, or just chloroethylene. It doesn't matter if it's attached to 1 or 2. It becomes 1. Yeah. Jordan. Okay. Yeah. Yeah. You gotta go. Okay. So hopefully you can recognize that the monomers that we're going to get from these polymers, the single bond came from a double bond. And so this is, how many fluorines are on this ethene? 4. So that would be tetrafluoroethene, right? So this is tetrafluoroethene. And this is going to be what? The polymer that you make from tetrafluoroethene is going to be what? What are you going to stick in front of this name? Polytetrafluoroethene, right? So now this is polytetrafluoroethene. Or ethylene or whatever. This is, what 4 letters do you think we would use for polytetrafluoroethene? P, T, F, E. PTFE. And so if you ever see something on the bottom that has PTFE in it, this is Teflon. Has anybody ever heard of Teflon before? Yeah. This is Teflon. This is the Teflon coating used in frying pans. This is the non-stick, relatively durable, kind of not really, but relatively durable, yeah. Okay, so So this is the way I would show it. I would show two monomers reacting, and then I would say plus ... just to show that, yeah, there's a bunch of these reacting over and over and over again. For the second one, hopefully you can see that right, this thing plus itself a buttload of times. Are we good with addition polymerization? Yeah? Okay. Okay. Condensation reactions. You're pulling water out of this thing. What other reaction do we know you get water as a product? Yeah, esterification. And what two things do you need in order to make an ester? An alcohol and an acid. Now, if you want to make a polymer, using condensation reactions, you need some sort of a molecule that has, well, it's got to have an acid on this side, and we're going to react it with what? Acids react with alcohols, right? But that will make one connection. What do we have to have on the other side of this molecule? If we want to react this thing with something else on both sides,
An open bond.
no, we don't need an open bond. You can't have like an open bond. Okay? What did it take to connect these two things together? An acid and an alcohol. So what should we have over here?
An acid.
An acid and alcohol. We can have a diacid reacting with a dialcohol. No, it probably won't. Maybe it won't make a cyclo thing. So this acid can react with that alcohol. And what can this alcohol react with?
The acid on the other side.
The acid on the other side. But maybe not the acid on the other side. It can react with another one. Remember, polymerization reactions, you want several hundred of these, or maybe dozens, or maybe thousands of these to react over and over and over again, right? So what are we going to pull out from between this acid and alcohol?
Water.
We're going to pull out a water. What are we going to pull out between this acid and alcohol? A water. What are we going to pull out between this acid and alcohol? A water. Do you see how very quickly we're going to pull out a lot of water molecules during this process? Yeah, so that's the idea. That's what we're trying to do. This is a dicarboxylic acid. Do you see how it's got an acid on both sides? And then in the middle is a bunch of junk. We don't particularly care what it is, as long as it begins and ends in an acid. Now, something that begins and ends in an acid can react with something that begins and ends with an alcohol. And we can get this process going over again. What kind of a bond, what kind of a functional group do we make when we have an acid and an alcohol reacting? An ester. So you're going to get an ester here. 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 What do we call that?
Polyester.
Whoa.
Whoa.
Boo. It's okay, you can boo me, that's fine. So draw a structural formula equation to show the repeating unit of condensation polymer formed from the following compounds. Okay, sure, no problem, whatever. If it's okay with you, I don't want to do a structural equation, I want to do a line diagram. So how many carbons are in this dicarboxylic acid? 4. So 1, 2, 3, 4. And what's at the beginning and end of both sides of this?
Oxalic acid.
Oxygen.
And what is it reacting with? How many carbons in this dialcohol?
4.
1, 2, 3, 4. 1, 2, 3, 4. And what's attached to this carbon?
The hydroxyl.
The hydroxyl group. And what's attached to this carbon? The hydroxyl group. Plus dot dot dot. You just have to show me one. Okay? So this thing is going to react with that thing. On the opposite side, on the right-hand side of this alcohol, what is this going to react with? Another one of these. It's not this side of it, okay, but it's going to be another one of these, okay? So it's going to react many, many times. Now, when we do this, what are we going to pull out of here? We're going to pull out a water. So we're going to get H2O, and we're going to get N of them. We're going to get a buttload of them. We're going to get a number of them, right? That's all we care about. What's my new structure? What is my new structure going to look like?
Oh, H1.
Okay, so remember this side at the beginning, does this side react as well? If we're going to get a whole string of 1,000 of these, is this side going to react as well? So what you're going to get is on the one side, you're going to get that O, and it's bonded to something, right? And then how many carbons? Right? 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons. This carbon is no longer bonded to an OH. What's it bonded to now? An O. And it's bonded to 4 carbons, right? 1, 2, 3, 4. Holy. Do you see how this quickly gets out of control?
Yes.
Like this quickly, very quickly gets out of control. I'm never going to ask you to do a condensation polymerization reaction by writing it out. But I will probably ask you what type of polymerization, and you have to tell me it's a condensation polymerization reaction. Majority question.
So is the only byproduct of the
Yeah.
So water.
And your polyester, right?
So making polyester is water? It doesn't,
Will you get water out of it?
like pollute though?
Well, what do we probably have to have as a catalyst here? Why do we have to have H2SO4 or H+? Why do we have to have that as a catalyst? Yeah, we got to kickstart that reaction, right? Absolutely, we have to kickstart that reaction. Is that okay? Yeah. All right. We're not going to be able to get to the lab today, so we're going to do that tomorrow. And then we're just going to finish talking about condensation reactions, and your quiz is going to start at 11:25:30. I don't think this is a very long quiz, so I just want to let you know right now. Yes or the no. Okay, go ahead. Yeah, Alicia.
Probably a super far question, but like at the ending of, like, where does it end?
It's at some point in time it's going to end, and it's just going to end with either an acid group or it's going to end with an alcohol group. Right? At some point in time it will end, and it's just going to end with an acid or an alcohol. Yeah. So it's not, I don't know, it's a little bit easier to see this than it was the addition, I think. Okay, perfect. So I would like you to try this question out. There's 2 questions on here. Yeah. I don't know, there's 4 diploma questions that I feel like you should be able to answer. Have you done it? Yeah. No. Oh.
Because technically ethylene is unsaturated. But since if we're talking about this, this is saturated.
That's polyethylene.
There's no attention.
You saved one. Thank you. I'm gonna try to contact this. You a sneakerhead? Well, I'm gonna try to find
Okay. Yeah. I was watching a documentary. Yeah. And like
There's like the
I don't know, there's a I think it was yeah. So I did see it. And I was like, holy yeah. Yeah. I would there's never in my life would I have thought like a pair of sneakers, like really nice, awesome looking sneakers would be several thousands of dollars. But yeah. What are you gonna do?
You know, buy his.
Yeah, you know. Yeah, you just look at it.
Or you buy him to sell.
Buying this, it's an investment, right? Yeah. Oh no. I'm gonna give you like 30 seconds to finish up.
Yeah.
How much do you want from me? $10. I got
For solubility? Yeah, like the more branched something is. If I had an alcohol group, this on some sort of a hydrocarbon, okay? So we're gonna call it R, just as like a placeholder, okay? If there's not a lot of stuff here, how easy is it for water to get in here and like hydrogen bond? It's pretty easy, right? So for example, methanol, it's pretty easy. There's not a lot of crap in it, right? But if I have a carbon, do you know what I mean? How much easier is it for the water to get in here? It's not.
But that will have a higher.
This will have a higher boiling point. Yeah, much higher boiling point. Because it's got so much more London forces. Because all of these electrons, if I were to take this, if I were to take another one of these, right, the electrons in this molecule are attracted to the electrons, or sorry, the electrons in this molecule are attracted to the nuclei in this molecule. The more electrons there are, like bigger, the bigger something is, the stronger the forces. Okay. This first one, polyethylene terephthalate, more commonly known as PET, is used to make polyester textiles, blah, 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 blah. The polymerization reaction classified above is what's going on here? B. So it's a condensation reaction, right? How do you know it's a condensation reaction? Acid alcohol, right? That's a really, as long as you can recognize that, then that's really good for you. So it's definitely not an addition reaction. And what's the inorganic product? Water. Good. H2O. Perfect. Ethene. Okay, you don't. I want to be very clear. You don't even need this top stuff to answer this question. Do you know what ethene looks like? This. So is ethene aromatic? No. Is it saturated? No. Is it unsaturated? Yes. Move on. Would you be happy if you saw any of those questions on the diploma exam? Yeah, this is like, if you know your stuff, organic chemistry is relatively straightforward. Okay, ethene is what? Monomer or polymer? We haven't, it would be a polymer if it was what? Polyethylene, right? So it's a monomer and is converted into polyethylene by what? Polymerization. Good. And then the last question. Which of the following monomers is required to produce the polymer in the structural diagram above? Can you see a repeating pattern? Yes. I see either this as our repeating pattern, or you could say it's this. You know what I mean? Like, it doesn't really matter. So it's carbon-carbon with a chlorine on it, and instead of a single bond, it should be a double bond. That's where the monomer came from. So we're looking for carbon-carbon with a chlorine and a double bond. Carbon-carbon chlorine, double bond, no. Carbon-carbon chlorine, single bond, no. Carbon-carbon chlorine, double bond, yes. Is that okay? Yeah? Tomorrow we are going to, I'm going to introduce a small project for you. And it's the idea of the concept that is, I find, most important. And I'll just give you a little bit of a hint right now. The project that I want you to start working on is I want you to make, think of it as if you were pitching to somebody. Do you know what I mean by pitching? Pitching an idea?
Yeah, Shark Tank.
So yeah, exactly. Shark Tank or Dragon's Den, right? The Canadian version of Shark Tank, okay? So I want you to pitch the idea of a game. Now it could be a game show, could be a board game, could be a card game, could be a whatever. And inside that game, you have to somehow include some version of an organic reaction. You have to include some version of organic, chemical, physical properties. Do you know what I mean? So there should be questions related to that or aspects related to that in the game. Is that okay? So I'm going to give you a sheet of paper and I'll have all the rules in the rubric tomorrow. But for right now, let's start our quiz. Hey, we're basically done Chem 30. Are you happy?
Not really, because
I'm sad.
it just means diploma's coming.
Oh, it just means the diploma's going to be closed. Ah.
That's very scary. That's a scary thought. Why did we decide to take this class in Iraq? Who thought that was a good idea? Yeah, we. I'd be gone.
What?
Want to show you some nipple tests?
Remember that guy?
Yeah. Sorry, I thought I handed out 9. I thought I counted. Okay, the quiz has started. Go ahead and read through it. Let me know if you have any questions. When you're done, you're more than welcome to just put it into the bin. Oh, yeah, that's fine.